my name is Andreas, and today I want to show you some basics concerning Docker, also called a story of whales and Kraken. We start with containers. So what exactly are containers? Let's keep it simple. So imagine you have this little friend, a giraffe, and a bird, and a dolphin, and they want to play with each other. The only problem is they are all talking different languages. So the first thing they try to do is that they define a contract or a common language. Think of it something like English or Esperanto that they define so that they can talk to each other. These makes things a little simpler, but there is still a problem. Giraffe lives on land and trees. The bird lives in the sky, obviously, and the dolphin in the water. So they are still somehow separated. What can we do? Easiest step. Put them into containers. Containers, think of this like these little boxes. So we put the little giraffe here, and the bird here, and also the dolphin. And now the important part, together with the environment. And the environment could be something like PHP, like Java, or like C#. And of course, let's still not forget about the common language, the contract, which is basically HTTP, something you already know, at least if you're using a browser. And that's it. If you put your application into a container with your environment and abstract everything with HTTP as a common language, you already understand how containers work. What you could also do if you are into genetics engineering, just mix all the things up and you will end with something like this, which looks kind of cute on the outside, but maybe, just maybe, is not the best idea. Okay, some basics concerning Docker we will see later on. Images, container, and registry. What are these three things? So we start with images. Images, as it says here, this is just a static persistent image, something that looks like what your application looks like. These things will be stored in a registry. Think of this like this big bookshelf here. And during runtime, images become containers. So like it's here, images instance running an app process. So just don't mix things up like images and containers. Images are static, containers are running images. Just think of it like the difference between classes and objects. Push and pull, yeah. You can push things towards the registry or you can pull things from the registry. Volumes, also very important. If you have to store data, you have to store them in volumes. There are three different kinds. There is a so-called bind volume, which maps something from your local machine to the Docker container. There's an anonymous volume, something very rarely used, and a named volume. This is the thing you usually use, for example, for databases. There is also networks for abstracting several containers together and keeping them shut out from the outside. And of course, there's compose. So if you want multiple containers to work in a tandem, you need something like Docker Compose, something you also will see later on. There is management and monitoring. And of course, you could do more things. You could use things like Kubernetes, Docker Swarm, or for build automation, something like Ansible. But this is a little bit out of scope for this presentation. Okay, demo time. Good. Imagine we have a very small application, a Spring Boot application. We can just run it. Looks like this. It's building. Takes a while. And eventually it will spin up the application. There it is. So we have now an application that we can access on localhost 50,700. That just gives me the ability to do something with countries. This is just an example. So we have, for example, find all thing that just gives me a list of countries, or we have a find by ISO code, which gives me only country Spain. Okay, nothing new. Now we want to abstract this application in a container. So what is the first step? The first step is that we build the container and that we push it to the registry, remember. So we build an image and push it to the registry. How we are doing this? With Maven, also possible with Gradle, you can use the so-called GIP plugin. The GIP plugin is provided by Google. You have to configure some things like the so-called base image. So this is obviously the thing where your image gets based on, and we use Debian and JDK11, which is again the environment. You have to set a name. The name here just applies to some variables. So this is the name of the registry. Also the name of the artifact, and we just take the artifact ID from Maven here. Okay, then we can configure some things like memory, and that's basically it. And if we now have this profile activated and we say clean install, our application gets built, tests will be run, this is a usual thing, but it will also deploy everything to your registry. Your registry, while this is building, I will show you. Currently, everything is going to Docker Hub. This is a so-called public registry. Usually, if you're working in an organization, enterprise, you don't have a private registry, but for the sake of the demo, we are using a public registry. So this is Docker Hub. You can have an account here. You see my account is Goa Fabric. And now everything we deploy goes to this repository inside the registry, which is basically example servers, still building, I think, and now we are done. And now the new version of our image is deployed here as 1.4 snapshot. Should be, yeah, should be here, last pushed a few seconds ago. So what it basically did was building everything, and then it said using base image, building this thing and pushing it to Docker Hub. Okay, this was building an image and pushing an image. One thing concerning GIP, so for GIP, you don't need to configure anything more. GIP already knows about Spring Boot and it knows how to configure and build images for Spring Boot. So that's very nice. So as you remember, now we pushed the image to our registry. Now we have to pull it. So what we will do is just saying, I have to look it up. We say docker pull and then the name of the registry and the name of the artifact, and it will pull the thing from the registry. That is fast because Docker is using a thing which is called layers, which means only changes get pushed and pulled. So obviously we had not a lot of changes. So not a lot of things had to be pulled. And now after it's pulled, we can run this thing. And for this, we say docker run -p, the port and the image name. The port is very important. So we say -p 50,700. 50,700. One is the internal port and one is the external port. If we won't do this to the apply to the docker run command, the container would start, as you see here, but it won't be accessible to the outside. To have it accessible to the outside, we have to specifically configure the port. Okay, now it's running. And surprise, surprise, it should basically look the same like the container before. Okay, now the question. I have to stop this thing. For stopping, I use my Portainer, which you will also see in a minute. Remove. Portainer is a little application you can use to run and monitor your applications inside Docker. This is something you can also pull and just install very easily. Okay, now the question is, does it make sense to always say docker run? And if we have to configure more, we have to put a lot more into the command line. And it is not possible to run multiple containers together. Currently, we are just booting up the application and it works with an H2 database. But for example, if we want to also have it running in a Postgres database, so this is not possible, at least not easy. And this is where Docker Compose comes in. Docker Compose helps us with the configuration of our containers and also with the configuration and running multiple containers together. So this is now a more complex example. You see here, this is the so-called Docker Compose YAML file, which has multiple sections. Of course, first thing, we have the so-called services section. We have the name of our service, which is example service. We have the so-called container name, which is displayed either here, or you can also say Docker PS to show all running containers. Currently, it's not running. And then, most important, you have to apply the image name. It's the same we did here, Docker run. Currently, we have so-called restart no. You can also say restart yes, or you could also say restart on failure, which is usually the best thing. Our pod configuration is here, and then some environment variables. Then what we also have is a health check. So every 30 seconds, a health check gets executed and tries to take a look if the application is still running. It just does this by executing a curl, which is inside the container, and querying the so-called actuator health endpoint by Spring Boot. We have volumes we get in a minute, and we have this entry point. Usually you do not need to override the entry point, which is basically just the configuration of your Java process and how the application starts. I just use it for configuring the memory. And we have a network. Let's get back to the volumes. As I told you, we have different kind of volumes. The first thing we have here is the so-called bind volume. The bind volume helps us to map things outside the container to the inside the container. We are using this for the application YAML, which you see here, to map this inside the container, which gives us the possibility, if we want to change properties for our application, we can change it on our system and they will get mapped inside the container. So for example, if we want to say we want to have more database connections, we can change this here. Otherwise, we would have to log into the container and change it there, which is a lot of the hassle. But be careful, everything you have something like a bind volume, you can also destroy your application. So for example, if you have illegal changes here, this could affect badly your container. Okay, that's it. Let's just run this. For running, we can just say Docker Compose up, and it will start. And it will start in foreground. You can also send it to the background, but for the sake of the demo, let's start it in foreground. Starting up. Takes a while. And it should start with an H2 database. Started application. And again, we should be able to access the application. Yeah, there it is. You can also take a look into Portainer. And everything looks nice and shiny. Okay. But now we want to have a real database here. So I stop this. I say Docker Compose down, which removes everything. And now I bring in the database by modifying and adding things to the compose file. Yeah, I have a little trick here. So I just remove things commented out. Here we now have a Postgres, and we need to tie in the Postgres. So as you see here now in the service section, we defined a Postgres database. We again have a container name. We have an image, which is in this case Postgres 12, which is the latest stable version. We again have the pods configuration. So inside the container, it's this pod, and outside it's this pod. And we also have some environment variables. Badly enough, the environment variables are currently carrying unencrypted the username, the password, and the name of the database. This is something we could do better later on, but this is not part of this section. We again have volumes. We again have a so-called bind volume, which is initDB. This is a part that we find here. These are startup scripts that are executed the first time Postgres gets up. And we have, for the first time, a named volume. So a named volume just works like defining the name here, which is PG data. And this is the part inside the container, which is just where the Postgres stores its data. And we also have to define the volume here. And this is now a so-called named volume because we give this thing a name. So remember, this is a bind volume. You just see it by taking a look at it. So this maps the inside, something from our machine to the inside of a container. And this is the named volume. We can take a look in the, no, we will do this later. Okay. And we also have to tell the application how now to connect to the database. So I brought in some more environment variables. What you need to know with Spring Boot, you can define everything in your application YAML, but you can also bring in environments variables which somehow correspond to this. So currently we have Spring data source URL, and it points to JDBC H2 memory. And I can just override this with applying the same property here and saying, hey, I want a Postgres SQL database. And the Postgres SQL database is here. And we are not using an IP address or an endpoint here, but we are using a name. And this is the same name we are using here, which is basically the container name. So to make our example service connect to our Postgres, we need to have either the container name, or we could also use just the service name, which would only be Postgres, but at least under Windows, this sometimes makes some problems. Yeah, and of course, we have to supply the username and the password, and that's it. And now with the new things in, I can again say Docker compose up, and it should now not only bring up my application, but also my database. Takes a while. Again. And there we should have it. Yeah, we now see that we have a Postgres database, which is running here. And we also have our example service, which is still in starting state. And now it's running, and we can again access this. Okay. What we can also do, just to make some things clearer, is to connect to a container. We can just go into Portainer, connect here, and then I can show you. If we say ping Postgres, which is just the name, you see that the container is now connecting and pinging the Postgres database, which is just the logical name we defined in the compose file earlier on. And you see that the logical name ties into an IP address, which we have here. Please keep in mind, what will never work is localhost. So for example, if you would have the font idea of putting localhost here to your example service, you should remember this will not work because localhost from the perspective of a container is only the container itself. So this localhost is only the application, this is the example service. So it will never work and it will never be able to connect to your Postgres database. To connect to your Postgres database, you need to apply the logical name, which is a container name here. Okay, what we also have are networks. So you see here that our example service defines a network section, which is just example service net, and also our Postgres database also has a network. And you need to define the network here. The reason for this is that Docker Compose enforces us for all the parts that are inside the Docker Compose file that they need to be abstracted inside the same network. The network name you can choose freely. We could also have used called it Mickey Mouse. It would still work. But you need to define a network like this. So having a network defined here and having it defined here for every container, and then also having it defined here. The thing is, now that example service is able to connect to the Postgres database, which exists in the same network, in the same virtual network, but for example, our container, which is not in the same compose file and not in the same network, is not able to access it. So with this, you can easily have abstractions. So with every compose file, you need to know that you have a separate network. So containers from different compose file cannot communicate right away. If you need communication between networks and between compose files, you have to explicitly define this here and to define a so-called external network. Okay, something else, we can take a deeper look into Portainer, which really helps us a lot. So Portainer is a very nice tool that helps us to take a look into our running Docker instance. And we can see here, we have the containers here, which are the running instance. We have our volumes here. So we have our named volumes. And we also have the anonymous volumes, which I didn't show you early on. These are basically things for a temp folder. And we have also the networks. We have different networks here. So you can see this is our example service network. Okay, and that's it for now. Thank you very much. Have a nice day. Hope to see you later.